I believe I've mentioned this already, but I would encourage you when it comes to taking the notes here that you follow along and copy down the notes. The PowerPoints are posted on Blackboard if you want to print those out. I recommend doing the side-by-side slides and note lines for it. I definitely recommend when it comes to doing problems that you work them out with me, or possibly even when we get to a question or problem, pause it, try to answer it on your own to check yourself, and then unpause it, follow along with me working it out, and see if you got your answers correct. But especially for those of you who are online only or hybrid, you're only going to get teaching from me, instruction from me, the professor, if you watch things like this and read things that I type up. Otherwise, you're having to teach yourself this material, whether that be from the textbook or the online work or whatever it is. You have to teach yourself. And I always like to remind my students that my job is to teach and your job is to ask questions. But if you don't watch these videos, and if you are hybrid or online only, I don't check that you watch these videos, then you must watch them to get instruction from me. Otherwise, you really are trying to teach yourself a topic that you probably haven't learned before. Which brings me to chemistry itself. We're going to do an intro to chemistry, and I hope that a lot of this chapter is review. I really hope that we can lower the barrier and the intimidation factor that frequently comes with chemistry. I cannot tell you the number of times I have told people that I teach chemistry and high school physical sciences and physics and so on, and I get the response, "Oh, I hated that class in high school," or "Oh, I did so bad," and it breaks my heart because although it is an abstract concept, it is a weird one to understand. It has hands down become my favorite class to teach. It is a subject that I genuinely have fallen in love with. And although I don't need you to fall in love with it, I certainly would love if you did. I'd love if many of you considered changing majors and becoming chemistry majors if you're not already. But it's okay if you don't. It's okay if you don't love this. What I do want you to walk away from here, though, is having a basic understanding of it and not hating it. I would rather have one of your other classes, one of your other subjects be the one that you're like, that was the worst, not chemistry here. Anyway, we're going to really walk through things slowly here at the beginning. Like I said, I hope it lowers the barrier. I hope it lowers the intimidation factor. I hope a lot of this is review, but part of why we go through this is because I don't want to assume that you have been taught something in the past that maybe you haven't, or that you don't need a review of that stuff that you've learned in the past because it's been a while since you've done that. Especially here at community college, you know, some of you are coming back to education. Some of you are starting here in college right out of high school, but it's been a few years since you've taken a science or math course. And so you're just rusty on some of these things, and that's okay. And then we are going to touch on chemistry itself here. If you've had a chemistry class before, then again, hopefully it'll be review. But if you haven't, then this is going to be some new stuff. But it's real basic stuff here at the beginning. So with that, let's dive into section 1. Most of the times in the chapter, there's a couple little introductory things to the chapter and or the section. I am not going to read through the slides word by word or point by point here. I really want you to pause and take a moment to do that. A lot of times they're application, and we'll get into those applications in detail later on. And a lot of times there are specific life science applications. The second half of this series, Chem 111, is the chemistry of life processes. And many of you are taking chemistry because you need it as a medical, pre-med, nursing, whatever it is, major, or a veterinary track that you're on, and you're taking this because it's necessary for the life science stuff. And so a lot of them are life science applications. But we're not going to get into the details on a lot of the examples. I encourage you pause it and read it. If you've printed out the notes, read them there, of course, but I'm just going to gloss through a lot of that. I don't want to insult you by just reading everything here. I want to take what's here and elaborate on it and expand on it. So with that, chemistry is the study of composition, structure, properties, and reactions of matter. I would add that I tend to think of composition and structure as the same thing. Part of that's because I have a poster in my room that breaks chemistry into kind of 3 sections, and it lumps those two together, but we're looking at what matter is made up of, what its properties are, and how it reacts. And most people, when they think of chemistry, think of the reactions, but it's going to be a little while before we get into actual reactions, because we need to lay the groundwork for that by talking about what's going on first before we can get into a reaction, which is where things are changing. We need to see changing from what, so we have to understand what they were to begin with. And chemistry, yeah, happens every day all around you. I had a salesman who tried to convince me to buy his cleaning product because it had no chemicals in it. And he wanted to demo his project, so he cleaned my window and he cleaned my car tires, and he sat down and actually went there and scrubbed my porch and was trying to convince me that this thing doesn't have chemicals, and was angry that I let him do like an hour's worth of chores around my house and then didn't buy his like $50 bottle of cleaner. And I was like, it's got chemicals in it. No, it does. And what he meant is it doesn't have harmful chemicals in it. And sure, the natural products, maybe they're not harmful, but there's a lot of people who are afraid of chemicals. And the thing is everything is made up of chemicals. If it's stuff, it's made up of chemicals, and you have reactions going on in your body all the time, chemical reactions going on there. And so chemistry really does happen all around you. We're going to get into a lot of your uncommon reactions, a lot of forced reactions where chemists are wanting to cause this thing to happen, rather than just what occurs on its own naturally. But still, chemistry is nothing to be afraid of. Getting into those four subpoints here, composition is what's it made up of. Structure is how is it put together. So what it's made up of is going to be atoms. Structure is how are those atoms bonded together. From there, what characteristics does it have? What properties does it have? And from there, is it reactive? Does it react? How does it behave when put in the presence of other substances? And a lot of times in chemistry, that is not theoretically predictable. It's something that's been determined by experimentation, by chemists just trying this reaction and trying that reaction and trying that reaction. Well, now that we've tried them, we know how they behave, and we can start to draw some trends out of that and then make predictions. But there are times where experimentation is kind of a guess and check process. But reactions is how does it behave when interacting. So matter is simply a word for all the substances that exist in our world. To be honest, I'd like to think of it as stuff. Matter is stuff. More specifically, the proper definition is anything that has mass and takes up space or has volume. And so all of these things are matter. Pretty much anything you can think of that is not energy is going to be matter. I don't particularly love the textbook's description here, but chemicals are substances that have the same composition or properties wherever they're found. What they mean here is that if we have a chemical like water, it's always the same. If we have a chemical like carbon dioxide, it's always the same. If we have a chemical like sugar, its formula, its structure, its composition, how it behaves, its properties are always going to be the same. Here are a list of substances that are used in toothpaste, which is their example on the prior slide. You'll notice there's lots of different substances here, lots of different chemicals that you find in it, and most of these are your active substances, the ones that are doing things. A lot of times there's also filler substances there as well, especially in medication. That's the case. You'll have your active substance, which is the one that you want to run a particular reaction in your body to treat whatever it is, and then you have fillers in there so that your pill isn't microscopic, but it's something you can actually see and consume properly. Here we have our first learning check, and the chapter here is actually going to get into how the book is organized, but learning checks are questions, and like I said, I recommend pausing and trying to answer this one on your own and future ones on your own, and then seeing if you get the answers right when I go through it. But I'm going to go right into it because I assume you can work the pause button. Anyway, which of the following contains chemicals? Sunlight is not stuff. It doesn't take up space. It doesn't have mass. It is a form of energy. So it is not matter. Fruit, yes, is matter. Milk is yes, matter. Breakfast cereal is yes, matter. Hopefully that is really simple for you, and that finishes up section 1.